Let's start with a little bit of housekeeping here to begin. As you walked in, everybody got handed the review packet for the semester exam. There's one small mistake on the first page, so if you open up to the front cover, just the cover, the front page, very front, the very, very front. The due date says December 15th on the paper. That's a mistake. It should be the 14th. So please change that on your paper to reflect that the due date is December 14th. 1/4, December 14th. So just a little bit about your exam. As with all exams, 15% of your overall grade for the course. For this class, the exam is going to cover chapters 1 through 5. Note that we're on chapter 5 right now, so the material we're doing right now will appear on the semester exam. The equation sheets in the content library I will provide to you on the final exam. So if you look in the content library, we got some equation sheets here, whatever, 4 pages of it. I'll give you all of that. You're going to get 2 to 4 questions per chapter, depending on the amount of required to answer that question, or those questions, I should say. The exam format and question types will be similar to those found in the review. So all the chapter 1 questions will be grouped together, just like in the review, all the chapter 2 questions, etc. Each chapter's questions, except for chapter 1, that'll be worth a little bit less, will be worth a similar amount of points. And this is the part that you'll probably care about. If you turn in this exam review before 2:45 on Thursday, December 14th, that's the last day of classes, I'll give you 5 points of extra credit on the exam, and I'll pass your review back to you and allow you to use it on your exam.
That's so nice, thank you.
Okay. Seemed unnecessary, but...
I'm just so excited. That's actually...
Wait, this entire thing was on our exam?
Yes.
I think the initial day reviews.
So, just as a fair warning now, the key for this review, I will not be posting until 2:45 on December 14th. So the work that you do needs to be your own on the review. Now, before you turn that in, I would recommend to you taking a picture, making a copy, whatever, so that once the review key is posted, you can kind of check what you did to make sure, I have to be careful on number 7. I did that one completely wrong. Let me make sure I study that part, right? You'll definitely want to do that. Now, can you ask me questions about the things on the review? Sure. I will answer individual questions about problems from the review. That's fine. Can you write, what kind of work can you write on the review? Anything that's relevant for doing that type of question, you could write on there. So you can include notes to yourself about hey, the first step to do a problem like this is I need to check this thing or that thing, and I need to remember that this is equal to that. You can write general procedural notes to yourself on how to do that type of problem. My suggestion to you is to be as thorough as you can when doing this review, because just having a correct answer on it does little to help you using it on the exam. You'd really want some detailed instructions or work shown so that you can follow that in the future when trying to do a problem similar but not identical to the one on the review, right? Do you guys feel okay? Yes.
So throughout the semester, we have a bunch of equations and stuff that we put on our note card. Should we just include those problems?
If it's relevant to doing that problem, I would certainly put it on there.
Okay, but they won't be doing this, like,
The equation sheet that I'm giving you is posted in OneNote. So again, if you want to, I would suggest, again, having that out, looking at that while I'm doing the review. But if there's things that you would like to use that aren't on the equation sheet but are relevant to one of the problems on the sheet, I would write that down as a note to myself. Be like, hey, now I need to solve for blah, 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 using this formula, blah, blah, blah. You know? And that's no problem. You can certainly do that. In fact, I would encourage you to do that. What is this really that we're doing when we're writing this review? You're studying, right? This is the way you'd want to approach studying for a math test, whether that's next year in college or next year at Notre Dame, right? This is the way you'd want to study for a final, as you go back and look through the major kinds of problems that you do. You want to outline to yourself how you do those problems, procedures that you would need to follow, or the information you need to have, so that as you're studying, you know you have everything together in one place and you're not hunting and pecking and trying to make up reasons why you're doing things. Right? Any more questions about this? Yes, Jacob? It should be relevant to the problem in there. So you should have anything relevant to doing that kind of problem. You can include in the space where that problem is. But general notes, probably no. Okay? But again, remember look at the equation sheet on the OneNote there to see what I'm giving you, because there's, a lot of good stuff in there. Yes.
Will everything on the study guide be in the study guides that you gave us for each chapter? Or is there stuff like in the notes that wasn't on?
I think it's pretty representative of what we tested on.
Okay.
I'd find it hard to believe that there's something that we didn't that I didn't put on the test, but I found valuable enough to want to put on a final. You know what I mean? Again, I wrote this thing long ago, or the versions of this thing long ago. Okay. Everybody feel all right? Why are you getting this now? Well, probably some of us are going to want to start getting our things together over the weekend. I wanted to make sure you have plenty of time to look at this and spend some time with it, right? And especially since I'm not providing a key until after it's due, right? Okay. Today, what we're going to do is we're going to work on, from the homework, we're going to do work on 47 to 62. But before we do that, I guess I should see if anybody has questions from the 1 through 6 that we've assigned already, that I don't think we've taken any questions from. So before we start that, on 1 through 6, does anybody have anything they want to talk about? Grace? Sure. Oops. Jack. So it says find secant if cosecant equals -3 and cotangent is positive. So cotangent being positive also would tell me that its reciprocal should be positive, right? So now I'm going to go and look for an identity that relates cosecant, the thing that I know, with either tangent or cotangent, the thing that I know something else about. So if I look at my identity sheet, again, I would encourage you to take your identity sheet out and follow along with me. If I look at P2, I see that 1 plus cotangent squared equals cosecant squared. So if I plug in -3 for cosecant squared, 1 minus -3 squared is 8. And if I square root both sides, cotangent alpha should be plus or minus the square root of 8. But I know that cotangent is positive, so I know it's not plus or minus, it's just plus. I can simplify that a little bit. I know that 8 is 4 times 2. So the square root of 8 can be the square root of 4 times the square root of 2. And the square root of 4 is just 2. And then similarly, I know that tangent would be the reciprocal 1 over 2 square roots 2. Now, I'm not going to worry about rationalizing a denominator there because I'm really interested in secant, not tangent. So I can simplify that if I wanted to or not. It doesn't really matter. So now I'm going to look for an identity that involves secant, cosecant, and then either cotangent or tangent. It doesn't matter. So that identity appears to be Q. Let's see, let's do Q1. So that says that tangent alpha equals secant alpha over cosecant alpha. I know that tangent is 1 over 2 root 2. And cosecant is -3. So to solve for cosecant, I'm just going to multiply both sides by -3. To get the secant by itself. And then I'm just going to rationalize the denominator now, since I realize that, oh, this is approaching a final answer. Grace, is that okay with what I did there? Okay. I tried not to go too fast through that. Normal fast, but not too fast. It sometimes takes a minute to kind of process. So notice along the way, I didn't really know what I was going to need. So every time I got some information about one of the trig identities, I could say the same thing about its reciprocal, right? I could also say something about the reciprocal right away. You know, like if cotangent's positive or positive, I know tangent's also positive. If I know cotangent's the square root of 8, I know tangent's 1 over the square root of 8. And I can always kind of say those sorts of things. Miriam?
So when you did the plus or minus square root of 8, and you did is that just like were you just doing algebra there?
When I turned root 8 into 2 root 2?
Yeah, like was that like something that
Yeah, you would have done that in like your Algebra 1 class. So like 8 is 4 times 2, right?
No, I know that.
So square root of 8 is square root of 4 times the square root of 2. So just 2 root 2.
No, I know. I thought you were like
No. I just, yeah, like Algebra 1. Or Algebra 2 again, right? You probably do it there also. I think so. I think I did it when I used to teach that course. It's been a while since I taught that course. Should have. All right. So the next part of our assignment is going to be like 47 to 62. We're going to do as much of that today as we can together as a group, just like we did for the homework 7 through 13. I think we had 2 people absent, right? Francesca's not here. Are you, Francesca? And Lexi Birchmeyer's not here. So that's really convenient. So we're just going to take Jake and Maya, and you guys will end up being partners then. No, partners is good. Okay, so I would suggest getting up and moving so you can sit next to the person that you're partnered with. You should have your identity sheet out, at least one for the group. On top of the file cabinet, there are a bunch of them. You're welcome to another. Absolutely.
Yeah, I'm moving.
I'm pretty loaded on this. John,
Sure.
You never told me about that.
How do you think he is doing?
One day I want to know.
I don't like him.
Sure.
Like, okay.
Okay. All right. Let me talk a little bit about this new kind of problem that we're going to be working on today. So the directions for this kind of problem are going to say prove the identity or verify the identity. Don't be scared at the P word here. This is no more difficult than the problems that we did in the last class. And I would say, in fact, in a way, these problems are easier because the answer that you're trying to simplify to is provided to you. So if you have an identity and you're asked to prove it, the goal is to start on either the left-hand side and use algebra or identities to turn it into the right-hand side, or start on the right-hand side, use algebra or identities to change it into the left-hand side. My suggestion to you, in general, is typically you'd like to start with the more complicated side and try to turn that into the less complicated side. Most often, simplifying in that direction tends to be more intuitive. Can you use either side? Yes. Could it be tricky if you pick the less complicated side? Yes. Should you try to make your life as easy as possible by making good choices? In all facets of life, yes. So if I look at this first identity, Sarah and Iden, which side appears to be the more complicated of the two sides? The left side of the equal sign or the right side of the equal sign?
Left side.
The left side. Seems pretty obvious because you have more trig things going on the left side than the right side. I'm sure that every one of us would have said left, correct? Okay. So, Sarah and I, looking at the left side, would you like to start by doing an identity or algebra? Okay. What identity would you like to apply here? Let me give you some guidance. If you're not sure what to do, look at where we're trying to go. The identities on the right-hand side are all either sine or cosine. So what I would be looking for with my identities on the left-hand side is figuring out a way to change cotangent into something with only sine or cosine in it. Similarly, I would want to do the same thing with tangent, change it into something with only sine or cosine in it. Because I know at the end of the day, that's all that should be in my answer. Does that help, Iden and Sarah? Excellent. So let's use Q1 and Q2. So Q2 will change cotangent into cosine over sine. And Q1 will change tangent into sine over cosine. And then everything else kind of stays where it is, right? Let's do some highlighting here to make this clear. Is everybody okay with the reasoning that we used to make that decision of what identities to use and how we applied the identities? And I'm going to do this frequently. Encourage you to go back and look at where are we trying to get to. That'll really help motivate us to choose the right things to do, whether it's an algebra thing or an identity thing. Looking at where you're trying to get to often has a lot of clues. Miriam.
So I never used 22, but like I thought like you said like if there's like something squared in your end,
Yes, but if you look, we're working on the left-hand side, and there's nothing on the left-hand side that has anything squared on it. That's okay. Grace and Maura, what should we do next? Algebra or identity? Great, I agree. What would you like to do algebraically? Great, so that's a good idea. If we look at the left-hand side, I notice that there's no multiplication going on the left-hand side. So probably stands to reason that I need to do the multiplication here on the left-hand side to take care of that. So when I distribute the sign, I'm going to have sine x times, and then that fraction, cosine over sine. And then I'll have sine x times cosine x, and then sine x over cosine x. Wade and Kate, what should we do next? Yeah, so the first fraction, I can think of that as sine x over 1. So I can reduce that fraction. In the second term, I can think of sine x over 1 and cosine x over 1 and reduce that fraction. So now when I multiply things together, what does that first term become? Excellent. And what are we trying to get to? What are we trying to get to? That, exactly. So what does that tell us? We're finished. Notice as I did this problem, I worked vertically down my paper. That's kind of the standard, where I just leave a blank equal sign on whatever side is staying the same. Is everybody okay there? So it's kind of like I've just taken this side, and that all just stayed the same, right? Grace? Awesome. Those are my favorite kind of questions. The ones that spontaneously answer themselves. All right, let's see. We'll grab the next one. All right, let's see. Miriam and Jacob. What side should we start with? I agree. So, to be clear, it's tempting for a lot of students to think that the fraction would be the more complicated side. I disagree. What you'd want to see is the left-hand side has two terms, something plus something. The right-hand side has only one term. In general, it's going to be easier to take two things and combine them together into one than to take one thing and break it up into two. Everybody okay with that idea? So even though that fraction looks scary, it's just one thing. It's in fact simpler than the other side, which has two things, even though there's no fraction on the left side. Okay. So Jacob and Miriam, you decided to do the left side, which I agreed with. Would you like to do algebra or an identity? Great. If you look at that, there's no algebra to do, right? You just have two things adding together and they're not like terms, so what could I possibly do? There's nothing to do. Let's look for an identity. Or identities. let's make a suggestion to you. Did you look at where we're trying to get to? What trig functions are in the right-hand side that we're trying to get to? Sine and cosine. What kind of identity should I be, or what should I be looking to turn tangent and secant into? Sines and cosines, right? Okay. Q1 will turn tangent into sine over cosine. I like that idea. What about the secant? What can we do with that?
Is it like another thing?
You want to have it with...
Would be an R.
Yeah, which one?
Probably has to be a sine.
Or a cosine.
R5.
Yep. So again, the goal here was, when we looked at the final answer, we saw just sines and cosines. Reasonable to say, okay, first step, I'm going to use my identities, get everything with sines and cosines in it, get rid of all the tans and secants. So I just have sine and cosine to work with. You guys did that effectively. Jake and Maya. What should we do here? Okay. And why can we do that? Great. We notice that we have a common denominator, so we should be able to add the fractions. When we add fractions, the denominator stays the same, and then we add the numerators. What do I get when I add those two numerators? Sine x plus 1. I'm going to write it as 1 plus sine x because I think that looks a little bit cleaner to me. So far, so good. Okay. Jack and MJ. What are we thinking here? So probably be the trickiest thing to come up with for all the problems that we're going to do today. So you guys landed on a good one.
Right. So, well,
Algebra identity. Let's start there.
I think algebra.
I would agree because we already have our right-hand side with sines and cosines in it. We don't want to change that. We just need to rearrange it somehow, right? Okay, good. Algebra. What are we going to do? When you say multiply by cosine, what do you mean?
Multiply the top by cosine.
Well, we can't just multiply the top by cosine. That'd be like saying, if I take 3/4 and I multiply by 5, it's still the same thing as 3/4, right? We can't really do that. But you're on the right track. Let's make a suggestion. So let's look at where we're trying to get to. I'm going to focus on the denominator. I want the denominator to be 1 minus sine x. I look at my denominator. There's no way for me to use an identity to change cosine into 1 minus sine x, right? So what I'm going to do is I'm just going to multiply so that I can stick a 1 minus sine x down into that denominator. How do I do that? So I need to do whatever I'm going to do. It has to be to both the top and the bottom, right? If I want a 1 minus sine x in the denominator, I'm just going to put it in the denominator. And then whatever I did to the denominator, I have to do the numerator, else I've changed the value fundamentally of the fraction. Because right now, all I'm doing is multiplying by 1, which doesn't really change anything. It's just going to rearrange it, which is what I want to have happen, right? Now that's a tricky thing to come up with on your own, having never seen it before. So now, how do I multiply these two fractions? So cross multiply is a solving technique. Here we're simplifying. Just straight across. Numerator to numerator, denominator to denominator. So 1 plus sine x times 1 minus sine x. That looks kind of like something I should remember from Algebra 2. When I look at that, that looks like an a plus b times an a minus b, right? Do you guys kind of see that? Do you remember what that's called from your Algebra 2 class? We are going to FOIL. This specific kind of FOIL problem, though, is called a difference of two squares. Because I know that a minus b times a plus b should be a squared minus b squared. Most often in Algebra 2, you use this fact to go that direction as a factoring pattern. In this case, I'm going to use it as a multiplication shortcut. So my a in this case is 1, and my b in this case is the sine. So when I multiply this out, when I do my foiling, I'm going to get 1 squared, which is 1, minus sine squared. Is that okay? Is everybody okay here? Why didn't I multiply out the denominator? The answer is, look at where I'm trying to get to. My denominator should not have a cosine in it, correct? At the final end, the only way I'm going to be able to get rid of the cosine that's in it currently is to reduce the fraction out, to reduce that cosine out. To be able to do that reducing, I have to have the thing in factored form. So why would I multiply it out if I'm just going to have to refactor it later to do that reducing? That's my explanation. In general, probably don't want to multiply a denominator out unless you have a good reason to do it. Now, is it wrong to multiply it out? No, you're just going to make more work for yourself when you have to factor it back, like a step or two later, but that's okay. So, just to review the trick that we've shown you, we're at kind of an impasse. We had no identity to turn the cosine into a 1 minus sine x. So what did we do? We just multiplied the top and bottom by a 1 minus sine x. As an extra confirmation, when I see that one of those multiplications, either the numerator or denominator, is going to result in a perfect square, usually that lets very nice things happen in the future with identities. That's an extra, I'm excited to see that. It really makes me feel like I'm doing the right thing if I can get a difference of two squares going somehow. Does that make sense? Again, I'm trying to talk about like what I'm, yes, go ahead. Yeah, absolutely. Like what I'm looking for when I'm looking at one of these problems, what I'm seeing, how I know to do that, like what are my clues along the way, right? All right. Andrew and Charlie. We're now here. What do you guys want to do? Algebra or identity? I agree. Oh, no. Wait, what algebra do you want to do? So, what are you trying to do now? I'm sorry, you're just talking kind of quiet and I couldn't hear.
Oh, on the cosine x and then a bracket, which one? Take care of that.
Well, I wouldn't multiply that out because if I look at where I'm trying to get to, I'm supposed to have a 1 minus sine x down there, right? So that cosine has to get out of there somehow. Probably it's going to have to reduce out when I reduce a fraction. So what I'd be more interested in is trying to work on 1 minus sine squared and try to get a cosine out of that somehow. So I'm not going to be able to do that algebraically. I would be looking at my identities to see if there's something there. Yeah, I think that's a great idea. So using P1, we can replace the 1 with sine squared plus cosine squared. Then we still have the minus sine squared now in the numerator. And Hannah and Dominic, what are we going to do now? You might be thinking, Mr. Kulik, that numerator looks worse to me now. After just applying that identity, that seemed like a foolish thing to do. And I would say, look a little closer at what's happening in the numerator. Mai's excited because I think she sees it.
Oh, wait. Take out the sign.
Take out the cancel out the sign.
So if we combine like terms, I have a plus sine squared and a minus sine squared. Those combine to give a 0, right? Now what can we do?
Cancel the two cosines.
Yeah, so I can reduce the fraction. So I can reduce a cosine from the numerator with a cosine in the denominator. Because I've left my denominator in factored form, I can do that reducing. And look at what I have. We are done.
Was this like what ranking of difficulty is this question?
This one was, I think, a little bit of a tricky one.
Okay, are there harder ones on this?
Are there harder ones in this one? For sure. But are there lots of ones easier than this one too? Yeah. Here's what made this one difficult. If we look, we used just 3 identities to do this. What made this tricky was that step. Without that step, this was going to be rough to try to get to an answer. That was the trick on this one. They don't all have such a tricky step involved. Like the first one I think was fairly straightforward. All right. We're back to the top of the order now, I think. Iden, you're going to have to do this solo as Sarah's look like taking care of a bloody nose or something. So, which side would you like to start with, the left side or the right side?
The right side.
Okay, why did you choose the right side?
Because the squares.
Okay, I think that this is kind of 6 of one, half dozen of the other. Like, I don't think it really matters too much which side you pick. Although if you're asking me, in general, when I do a problem like this, I would probably have picked the left side because I'd rather have one thing in my denominator than two. The reason is if I have one thing in my denominator, I can split the fraction if I needed to at the subtraction symbol. If the subtraction is in the denominator, I'm not allowed to break the fraction. So it'll be fine to use the right-hand side. We're talking this through just to kind of illustrate my reasoning. Okay, so you want to use the left side or you still want the right side?
Yeah.
Yeah, you wanted to do it, let's do it. Okay. So we're going to do that. Are we going to do an identity or algebra here?
Identity.
Yeah, there's no algebra we can do with this. You can't reduce because of the subtraction in the denominator. Can't break the fraction because of the subtraction in the denominator. It clearly has to be an identity. You're 100% right. Which one are you thinking?
I'm thinking one of the odd even identities, like OE1.
So if I look, the odd even identities are going to let you change an x to a negative x or a negative x to a positive x. Our variables are all the same. They're all y's. I would not be looking at an odd even identity unless I had like sine of x and then like cosine of negative x or something like that where the inside of my trigs are different. Here the insides are all y's, so I would stay away from any of those. Does that make sense on what I'm saying? Okay. When I look at this, the denominator is what sticks out to me. Because when I see ones and then addition or subtraction of something squared, I think Pythagorean. Those are almost always going to be your best option in that case. For this particular one, which of the Pythagoreans would apply? P1. That is correct. And the way we're going to apply P1 is we're going to change the 1 in the denominator into sine squared plus cosine squared. And then we still have that minus sine squared in the denominator. All right, let's see here. Where is down to? Grace and Mora. What would we like to do next? Great. Specifically, what kind of simplifying are we doing? Combining like terms is the phrase you're looking for. So the sine squareds will combine to give you 0. That looks good. That was so easy. I'm going to ask you the next question. What are you thinking now? Let's think about where we're trying to get to. Specifically, I would be looking at the denominator. I need to have a sign y in my denominator. Is there any way with an identity that I can get a sign y in my denominator? Nope. Nope.
Oh.
So how am I going to get it down there then? Yes, I'm going to use the same trick that I used on the previous problem. I'm going to multiply the top and bottom by sine y. Good decision. Kate and Wade. You guys are next. Are you guys thinking algebras or identities? Okay. Yeah, if I reduce that sign out of there, I'm just back to where I was on the previous step. You could do that, but we probably don't want to. I mean, I could do R2, but look at where I'm trying to get to. Trying to get to this. Here is my suggestion to you. This is a trick. But what if we had written this as, instead of the way we've currently written it as one fraction, what if I separate off that 1 over sign so that I know that part's correct? That's the part I needs to be in the denominator, right? So I'm just going to kind of separate that off. And now I'm going to work with this part to try to get it into that. Is that a helpful hint there?
How would I know actually what? Yeah, like how do you know? I would never know to do that.
Okay. So sure, let's talk about, and let me reiterate what I'm doing. So we're at like an impasse of what to do, right? So I said, okay, well, the sign in the denominator I know is right. That part has to be down there. So let me write that off to the side as a 1 over sign. And then everything else I'll write together as just a multiplication problem. So I know this everything else somehow I'm going to have to work on turning into that. Right? So that's what I'm seeing when I look at the problem. It's happening very, very fast because I've had lots and lots of practice. But that's what I'm seeing. It's like, okay, what part of this I know is right? Can I separate that off and work with the part that I still need to change into something else? So what I would be looking at now, sine squared over cosine squared. Can I turn that into something? I'd be looking at my quotient identities. That is Q1, which allows me to turn that into tangent squared. Now that's not got a secant in it. However, if I look at that numerator of where I'm trying to get to, that looks like something I could use a Pythagorean with, right? Doesn't that look like something squared with a plus or minus 1 with it? Look at your identities. Look at what the Pythagoreans look like. They're all something squared and then plus 1 or minus 1 or equals 1, right? Is that what you see, Maura?
Yeah.
So whenever I see something squared and then a plus 1 or minus 1, I'm thinking a Pythagorean might be applicable here. So what I'm going to be thinking is now that I have this tangent, is there a Pythagorean that relates that tangent to secant squared minus 1? Let's see, whose turn is it now? Oh, it's Jacob and Miriam. What are you guys thinking here? Jacob, I see your hand up.
P3?
Yeah, so if we use P3, we see that that says tangent squared plus 1 equals secant squared, right? Yes.
Where are the sheets from last class?
On top of the file cabinet.
I didn't know what P1, 3, and... Thank you.
You're welcome. So what we have is tan squared, right? So if I subtract 1 from both sides, I can say that tan squared is secant squared y minus 1. So I'll call that P3 star since I've kind of altered it.
So you just like use the equation to like find what
The tan squared was, yeah. So on your equation sheets, or on your identity sheet, next to P3, you could write this also. You're now free to use that as an identity. That tan squared equals secant squared minus 1. Anytime you need to rearrange, particularly the Pythagoreans often get rearranged. Go ahead and write that on your sheet. You can use that now. Kate? Of course. Yes. All right. And then what's my final step here, Jacob and Miriam?
is this algebra?
Oh, yeah. Let me give you a hint. Cross multiplication is a solving technique. How do you multiply two fractions? Straight across. And is that what we're supposed to be at?
Oh, and now I'm going to the secant squared one. Yeah, I want to put that on top and.
So I would say all the other classes who want to do the left-hand side, I think the left-hand side probably ended up being a little bit more straightforward on how to get there. You didn't have to rearrange a Pythagorean to get there. But it's fine. You know, it still works.
I'm just so confused. How do you how do you remember like what to do? Like, is it supposed to is it like memorization?
Well,
or is it
for
more-
me,
well,
are
you're
you-
just
you're-
so smart.
well, hold on. One, I have all the identities memorized.
Oh my God.
You do not need to do that, but the more familiar with them you are, the faster this is going to go for you.
So how do you
So-
process what to?
Okay? So if I have a trig function to the first power, I'm going to be limited to the reciprocal and quotient identities.
Uh-huh.
If I have something to a second power, I might use a Pythagorean, but probably not unless I have also a +1 or -1 or something else next to it, or plus another thing squared or minus another thing squared.
Okay.
And really, those are the only three that I typically use.
Okay.
The odd evens, I'm only going to use if the variable on the inside of the trig function is different, like one is negative and one is positive. And I'll almost never use the cofunctions unless I have, like, on the inside of one of my trig functions, a pi/2 minus x.
Okay.
So almost always, I'm just looking at those first three types of identities. And then often what I'm doing to choose which one I might want to do, I'm looking at where do I want to get? What types of identities or what types of trig functions do I want in my final answer?
Okay.
And then I'm just trying to change the stuff that doesn't belong into something that does belong, is kind of what I'm doing. And now it happens really fast for me because I've done a million of these things.
Yeah.
But the first time doing it, it's hard. And that's normal. Okay. Let's take a look at the next one.
No, literally, where are the numbers? For here.
Oh my god, that's
Team over.
Let's see here. We have Maya and Jake. 50. Which side would you like to start on? Good, I agree. There's no way you're starting with the 2, right? Okay, what are we going to do first on the left-hand side? Algebra or identity? I agree. What algebra thing do you want to do? So the distributing 2 is wrong. You can't distribute an exponent, but you're on the right track. It involves that exponent. Not until you deal with the exponent.
So do we double?
Nope. So go back to Algebra 2. If you go back to Algebra 2, if you have this,
Yeah, that's what I was saying.
if you have this, what do?
You put it down twice.
Okay. I misunderstood what you meant when you said double, because that would mean times 2.
Yeah, that's what I meant.
Okay. So that's great. That's okay. That's why I wanted to, I thought I knew what you meant, but
Totally understand. I don't speak English.
I'm trying. You're trying. We're all trying. Everybody gets a little bit of slack, right?
No, because I would do the Then you just get what you want to start and be back to where we started.
There's a lot of work.
Okay.
This is one of the hardest ones I've ever seen in my life. And that's where you lost.
So, nope. What would I do now when I have 2 parentheses written next to each other? If I had a problem like that, what would you do?
Oh wait, isn't it the what's it called?
Yeah, what's it called?
Oil.
That's what I would do.
Oh wow. Dang.
So first, outer, inner, last, right? You remember doing that in Algebra 2?
It took me so long to learn. like we.
How?
Do you remember she said like one-on-one demos?
Oh my God, I remember.
Well, I'm going to do it real quick in my head here because, well, everybody just wants to get out of here, right?
Wait, who's we? You. Me? No, I'm kidding. I was Josh.
Okay, so let's see here. Who's next? MJ and Jack.
I mean, I'm still.
It is a lot of stuff. What should we be doing next? Algebra or identity? Good. What are you going to do? Combine the like terms. I love it. So I see I have a positive cosine squared and another positive cosine squared. I have a negative 2 sine t cosine t, and I have a positive 2 sine t cosine t. Those add to give me 0. And then I have a positive 2 sine squared t, or another positive sine squared t. That gives me 2 sine squared t's. MJ and Jack, what next? Algebra identity. I think it's still algebra time.
Oh, really?
There's one more algebra thing we should do. Ah, close. We're going to factor a greatest common factor of 2. So, because we can't do things to both sides, we can't divide the 2 out of there, but we can definitely just factor it out front. And now, Andrew and Charlie. I'm sorry, you said take the 2, and then you said it got quiet, and I missed it. Then you're back to where we were the previous step, right? You could do that, but it's not getting us, we're going backwards instead of forwards, right? Now I want to be clear, like it's not wrong to do that, it's just not helpful. Identity or algebra? Let's start there. That's always the question I want to ask myself after I write a new line.
I don't know.
Well, again, I look first for algebra, right? Is there any like terms to combine? No. Can I factor this anymore? Well, no. If I multiply it back out, I'm back to where I started. I don't want to do that. There's no fractions to reduce or fractions to add. So I don't think there's an algebra thing to do. So now I'm going to look for an identity. Absolutely, we would do P1. And we're done. You guys should all be following along while we're doing this. When I'm asking one group questions, you should be thinking, like, what is he trying to get to? Where am I trying to lead you to?
Okay, so I understand the last step.
Yes!
Woo!
Way to go.
One last step.
Okay, tell me last group.
You left proofs in geometry.
Do you remember when we had that proof test? You were It was so long. Oh, it's never ending.
I remember I got an 81.
You got a what?
Is good.
Oh, no. She's always fun.
All right. Dominic and Hannah. Left side or right side? So they say left side. Does it really matter, though? Look at these two things. This is like decidedly the same problem, right? Whether you start on the left side or the right side, it looks just like almost identical, right? The left side is fine. Now let's do that. To start, would you like to do algebra or identity? Algebra or identity? Okay, what identity would you want to use here? R6 to turn the cotangents into 1 over tangents. Yeah, we can do that. Yes, Charlie. Yes. Now this is going to get a little bit ugly for a minute, but that's okay. Well, just that we have like mega fraction here.
Oh, it's like fraction on fraction.
Yeah.
Wow.
We call that a complex fraction in the business, where the business is mathematics, because that's the business we're in. All right, back to the top of the order here. Sereniden. Again, I would suggest before we get going, look at where we're trying to get to and look at where we're at. Well, let me tell you this. It's not an identity.
Oh, snap, crack pop.
I would be doing algebra here.
Oh, do they cancel?
Do the tangents cancel?
No.
Do the plus and minus cancel?
No.
1.
No.
Cross multiply.
Do we flip?
Ooh, we got Smarty up here.
This is what you would want to do. So when we do that, we distribute through. What is tangent times its reciprocal got to be? 1. What's tangent times 1? What's tangent times its reciprocal? What's 1 times tangent? Guess what? We're done. Again, there's that sneaky trick that Mr. Kulik showed me, where if I multiply by the right kind of 1, like it just kind of makes all my dreams come true.
Wait, so tangent times 1 over tangent is tangent, right?
Tangent times 1 over tangent is tangent over tangent, which is 1.
So where is that? Oh, yes, yeah, okay.
Okay. So love that trick. Multiplying a fraction by 1. Super, super duper useful. All right, let me give you, I'm going to do one more for you guys here quickly as a bonus, so you have one more homework problem done.
Maybe 10 more?
Yeah, something like that. All right. I'm going to choose to work on the left-hand side. I'm going to start by rewriting tangent squared as sine squared over, it's just a variable, over cosine squared. That's actually the Greek letter beta. Everybody okay to there? What I see now, if I look at these as two fractions, the numerators both contain a sine squared, so I'm going to factor that out. Yeah, it's still the same variable all the way through. If it's easier, just write x's. If I look at my final answer, I don't see any fractions in there, so I'm going to use R5 to change 1 over cosine squared into secant squared. And then if I look inside there, that was my modified version for P3 that we just used a moment ago. And I know that's equal to tangent squared. And I'm done. That's how long they take for Mr. Kulik.
What side did you start on?
The left. So I started by changing, tangent squared using Q1 into sine squared over cosine squared. And then I used R5 to change that into that. And then I used P3 to change that into that. That's how long these take for Mr. Kulik. Actually, that was me taking my time doing it because I said what I was doing. These are 1-minute problems for me at
1 minute
best,
problems?
at
For
most.
Like 10 this is like 30 minutes for me. I think it might be infinity.
Infinity minutes.
I don't think I'm ever gonna finish one.
My friend just said the fruits are the worst unit.
That was the worst unit of geometry, let me tell you.
This is my favorite topic as a high school student. Was doing this.
You like to hear like our like brain process? Like pre-algebra was hard.
Here's what I my opinion. This particular topic taught me more about algebra than anything else I did as a high schooler, because you are punished by never being able to get the right answer if you make an algebra mistake. This taught me more about like when can I reduce, when can't I reduce, how to make sure I'm making common denominators, making sure like really, really, really forced me to get much better at algebra than I was at the time.
I feel like trig and algebra are like the same thing.
I don't know why.
Kind of.
How much harder is pre-cal? Because I don't know if I can do that.